We are still on Surds. In this video clip, we'll be looking at how to rationalize the denominator of a surd. On the screen, we have an expression here, 1 all over root 2. An expression like this is not always permitted in mathematics. Why? You can see here that the denominator there is an irrational number, root 2. We prefer to make sure that the denominator of any expression or an expression that is in a fractional form, that the denominator is a rational number. So how do we make this expression to become what? Sorry, how do I make this denominator to become rational? I'll take the 1 divided by root 2. To make the denominator rational, I'll simply multiply both the numerator and the denominator by the same numerator, the denominator rather. So I have here root of 2 divided by root of 2. Now, since both numbers up and down, that is the numerator and denominator, they are both the same. It's just like multiplying a number, say a by 1, where root 2 over root 2 is 1. So which means I have actually not changed the number, is still a. So whatever I'm doing here, I have not changed the value of 1 over root 2. Moving further, I multiply 1 by root 2 will give me root 2. That's for the numerator. And then divided by root 2 times root 2. Let's not forget that root of a times root of a is simply a. So root of 2 multiplied by root of 2 gives us 2. And that makes the denominator now a rational number. This is rational, as we all know. So we say that we have actually done what? We have rationalized the denominator of the expression 1 all over root of 2. Let's take more examples. First, we write this neatly. So that's it. The 1 over root 2 is equal to 1 over root 2 times root 2 over root 2. And that gives us root 2 divided by 2. You're going to take 4 more examples. Here we are told to rationalize the denominator of the following expression. The first one is 3 all over root 5. I'll take the same procedure, 3 divided by root of 5. To rationalize the denominator here, which is root 5, I'll multiply both the numerator and the denominator by root of 5. Now 3 times root 5, you will agree with me. This is 3 root 5 divided by root 5 times root 5, as we agreed earlier on, root a by root a will give us a. So this is just 5. So that's it. We have rationalized the first one. Let's look at the second one at once, since we still have space on this slide. Here we have 2 divided by 5 root 3. Ordinarily, we say, okay, let's just multiply this by the denominator. 5 root 3 divided by 5 root 3. Some people might consider this an overkill. There's no need for us to put the 5. We would have just used root 3 alone, but we will still get the same answer. So let's still go ahead. 2 times 5 root 3 will give me 10 root 3 divided by 5 root 3 times 5 root 3. 5 times 5, you'll agree, is 25. And then root 3 times root 3 is what? Is 3. I can do some simplification here. 5 here is 2. And 5 there is 5. So I have 5 times root 3. So 5 times 3 there. So the answer will be 2 root 3 divided by 15. You will get the same thing if you had multiplied both the numerator and the denominator by just using root 3. Let's write this out neatly. That's the first one. That's for the second. Yes, 2 root 3 over 15 for the second one. Now we are looking at question number 3. Root 3 divided by 2 root 3. Well, this time around, I'll solve them using both methods. Let me solve this by multiplying. This is root 3 divided by 2 root 2. Let's solve this by multiplying just using root 2, because that's the problem, the irrational number. Let's let the 2 just stay. Root 3 times root 2, you will agree this is root of 3 times 2. So that will give me root 6. Let's just write that in all. 3 times 2 divided by, now 2 root 2 times 2 root 2. This is 2. There is a 1 there. So 2 times 1 is 2. Now root 2 times root 2 is also 2. So that gives us what? That gives us root 6 divided by 4. What if I had used 2 root 2? Let's try again. Let's see if we get the same thing. This is root 3 divided by 2 root 2 multiplied by what? The whole denominator this time around. 2 root 2 instead of just using root 2 divided by 2 root 2. As we said earlier on, we're going to get the same thing. Excuse me. If I multiply this, my 2 multiply the 1 out there, so I have 2 standing. And then root 3 and root 2 will multiply to give me root 6. You will agree? And then, of course, this 2 multiplies this 2 to give me 4. And then root 2 multiplies root 2 to give me 2. Quickly, you can just do some cancellation there. You go. And that gives us what? That gives us root 6 in the numerator and then 4 in the denominator, which is the same thing as what we had here earlier on. So whichever way you want to do it, you will always arrive at the same thing. So we have rationalized the denominators of first 3 expressions: 3 root 5, 2 over 5 root 3, and root 3 all over 2 root 2. Next, we look at how do we rationalize 1 plus root 2 all divided by root 3. But before then, let's write out what we have done neatly. So that's it for question 3. Root 6 divided by 4. Let's rationalize number 4. Number 4 states that 1 plus root 2 divided by root 3 to be rationalized. So, okay, you are to be rationalized, no problem. We have no problem with the numerator containing an irrational number, so you stay. Our problem is with the denominator. Our problem is with the denominator. So we have here root 3. So we're going to multiply both the numerator and the denominator by that denominator, root 3 all over root 3. Now if we simplify this out quickly, root 3 times 1, you will agree is root 3. Root 3 times root 2, you will give us root 6. And dividing this, root 3 times root 3, that will give us 3. So simple, so straightforward. So that's it for the 4 expressions that we were to rationalize. Simply do what? Take the denominator, which is the irrational number, and multiply both the numerator and the denominator by that denominator. And then you'll be done. Next, we'll be looking at, let's write this out first neatly. Yeah. Next, we're going to look at the concept of conjugate pairs. We look at looking at finding the conjugate of a sword. What do we mean by conjugate pairs? Let's just look at that first. And in the next video clip, we will use the concept of conjugate pairs to rationalize much more involving sodic expressions. As you can see on the screen, I have the first expression a plus root b, and the second expression a minus root b. The difference is just that the sign joining the two expressions there has changed from positive to negative. We say that a minus root b is the conjugate. A minus root b is the conjugate of a plus root b. And we can also say that a plus root b is the conjugate of a minus root b. The same thing is applicable to the second line there. All that the difference we can have there is just this sign that's changing, so that both of them are conjugates of one another. That is, root a minus root b is a conjugate of root a plus root b. and root a plus root b similarly is a conjugate of root a minus root b, and that is also applicable to 5 minus root 3, 5 minus root 3 plus, and then 5 plus root 3. So also we have here 7 plus 2 root 3 and 7 minus 2 root 3. The difference you can see in all of them is that we have the same numbers there. It's just that the sign joining the two terms are different. So you try this. Give me the conjugate of 2 root 7 minus root 5 in 1 second. Are we there? I move. If you got this, 2 root 7 plus root 5, then you are very correct. That's the conjugate of 2 root 7 minus root 5. How about the next pair? Root 11 plus root 2. Who's getting this right? Straight. Just change the sign. We have root 11 minus root 2. I'm sure you can rush the remaining two. This will be root 3 minus 7. And finally, what did you get for the last one? 5 root 3 plus 4 root 2. If you got all these right, then that means you're ready for our next video clip. In the next video clip, we'll be trying out these problems. We're going to use the concept of conjugate pairs to rationalize these expressions. See you then.